Okay. So when you do an engineering drawing, it's used a lot of times for the fabrication part, making the actual product. So engineering drawings are used for the manufacturing people. So they have to include a lot of things like tolerancing, annotations, parts lists, right? And other information that's pertinent to making this part successfully. Okay, so it's needed for manufacturing and quality control. And yes, you're right, that's a milling machine that you see in the picture there. Okay, so some of the milling machines now are CNC, which means they're computer controlled. Computer numerical controlled machine, I think is what CNC stands for. And some of them are just still manually operated. So when you take Design 2, hopefully in the future, assuming you pass this class, you'll get to use milling machines and lathes quite a bit. And then maybe some CNC and some clean room fabrication equipment as well. So you'll get some hands-on in the next class with machining. Unless, of course, COVID blows up and no one's allowed on campus, and then we'll have to think of something else to do with you. All right, so format and contents, you're already starting to get familiar with it. You've got zones and borders and notes and title blocks. So that's the basic contents of a engineering drawing, a DWG file, for example. There are standards for sheet sizes. This is for printing stuff out. You can set that in SolidWorks, I believe. So if you have a big printer, access to a big printer, you can print out, blueprints and large detailed drawings in a fairly large size. So the machinists and all that prefer paper will have it in a standard format, okay? And these are some recommendations for creating zones for those big printouts. So, in the future, you might have a very complex design with lots of dimensioning and tolerancing information on it. So printing it out on a big field is useful. And then when you're talking to the manufacturing people as the design engineer, you can direct them to a certain zone, right? So F10, it's kind of like that game with the, Battleship, right? So you would go ahead and direct them to a certain part of the drawing using the zones. And that's why we have zones. Today everything's computerized and stuff, so zones are becoming less and less important, but just so you're aware of it. And if you ship your parts overseas to get made, right, you might ship a few parts to India, another one to China, and then 3 or 4 in the States, and then everybody sends you, 10,000 of each part, and then you assemble them at your site. So you might need to communicate with them via Zoom or some other system, and then point out specific details in the drawings by referring to the zones, or the person on the receiving end might have a question and point you into that direction. Okay, so that's why we have zones. And we've got metric and English units, so it just depends what you're using. Okay, so this is in millimeters. This is what a typical drawing will look like. I think we've gone over this, but if we haven't, or if we have, it's review. So you can see the orthographic projections. So you have a top view and a front view in this case, which is all you need to adequately define the dimensions and the structures on this part. And then we throw in a pictorial, and the pictorial is a 3D kind of representation of the 2D drawing, so that people can kind of see what it's supposed to look like when they're done machining it. And then it helps them visualize it and be more accurate on their dimensioning and tolerancing. Okay, so we already talked about zones. It's a letter number combination. So you say E5 and it's a hit, and you sunk my battleship, that kind of idea. Okay, the drawing scale expresses the ratio of the object's size as drawn to its actual physical size. So So the numbers you see there are actual sizes that you want the thing to be, okay? You don't have to draw it to scale, right? Meaning that if it's a 50-inch part, you don't need a 50-inch piece of paper, okay? Drawing notes are used in the drawings. This will become more obvious as we go through the semester. So you can write different notes in different blocks to give different sets of information to the people who are going to make your part for you. Okay, so here's a zoomed in look at the title block area. Okay, so in this case, and there's different layouts you can use for title blocks. So there's different parts to it, you know, and so you have a title, you have a revision, you have a drawing number, you have sheet. So sheet might be, you know, sheet 5 out of 27. So that if you're referring to a specific part or a specific sheet, you can refer to that. Okay, and any scaling information and that sort of thing you can put in there. And the book has more details on that. Revision history block, that's important because as you will learn in engineering, you're constantly updating designs. And as you update the designs, you have to keep track of what revision you're at. So it's like software is 2.0, 2.1, 2.3, and then major revisions, you come out with 3.0, 3.1, 3.3. So in the revs, you want, you know, which revision you're talking about. And that way, everybody knows which revision is the one you're speaking of, because somebody may have Rev 2 in their documentation and you guys might be on Rev 4. So always update the revisions, and that goes for your final project too. Okay, so immediately you know which rev you're on. And the date's always good. And it's good to have someone approve it. And typically the approvals are done by PE, professional engineers that are licensed to sign off on drawings. But it depends on what state you're working in. I think Texas requires PEs. New Mexico may not, right? So, you know, sometimes you have draftsmen. Old school is you have technicians that do most of the drawings, and then the engineers look the drawings over and make sure they're correct. And if they're correct, they sign off on it, so they approve it. Okay. So third angle projection is what we typically use in the United States. That's the one where you have the front view, the top view on top of it, right, and the right side view towards the right side of the front view. If you and you're looking at it from the front and the top. First angle projection is you're looking at it from what we would call the bottom. So there was a quiz question in the ILM that people got those two confused. So we'll have some more examples in the next lecture on that. Okay, so that's it for this lecture.